What really happens after a nuclear explosion? The world knows the flash, the roar, the towering mushroom cloud, but the true danger is what quietly drifts down from the sky long after the blast. It's called nuclear fallout, and its shadow can change life on Earth for generations. So, what exactly is nuclear fallout? It's the radioactive dust and debris sucked up by a nuclear explosion. Imagine the blast vaporizing soil, buildings, and everything nearby, mixing it with radioactive atoms from the bomb itself. These tiny deadly particles rain back down, sometimes minutes later, sometimes days, sometimes halfway across the planet. But what's actually in this fallout? Mostly it's fission products, unstable atoms like iodine-131 and cesium-137 created when the bomb splits atoms apart. There's also some leftover nuclear fuel and bits of material that got blasted by neutrons, turning them radioactive too. It's basically a toxic cocktail no one wants to breathe, touch, or even get near. Now, the way fallout spreads depends on a few big factors. First, the size of the bomb. The bigger the blast, the more debris. Second, where it explodes. If it's high in the air, there's less fallout because not much dirt gets sucked up. But a ground burst, that pulls a ton of radioactive material into the sky. And then there's wind and weather. Storms can carry fallout far and wide, sometimes circling the globe. Fallout comes in two flavors: local and global. Local fallout is the nightmare scenario. Heavy, radioactive particles fall quickly, blanketing the ground near the explosion. It's super dangerous. Exposure can be lethal within hours. Global fallout is more spread out. Lighter particles ride wind currents, drifting for days or weeks, sprinkling radioactive dust across the world. It's less intense, but it lingers, settling into soil, water, and food chains. So, what does this mean for people? Fallout radiation can deliver a fatal dose in minutes if you're close, or silently raise cancer risk over decades if you're far away. Scientists measure this threat in units: Röntgen for exposure, Gray, GY, for absorbed dose. At 1 Gray, you might feel sick. At 4 or 5, half of exposed people could die without treatment, a number scientists call LD50. Radiation attacks fast-dividing cells first, think blood, gut, skin, causing burns, nausea, immune collapse, and more. Here's the real question. If you knew this could happen in your lifetime, what would you do to prepare? How should humanity face the danger of fallout, knowing what's at stake? If this video opened your eyes, hit like, subscribe, and share it with someone who needs to know. Stay informed and stay safe.